Up where we left off on number 25. For his mathematics assignment, Armando must determine the conditions that will make quadrilateral ABCD shown below a parallelogram. Given that the measure of angle DAB is 40 degrees, which of the following statements will guarantee that ABCD is a parallelogram? A few things you need to know in order to prove a parallelogram, a quadrilateral parallelogram. You must have two things. You must have either two pairs of opposite angles congruent, one pair of opposite sides is both parallel and congruent, or two pairs of opposite sides congruent. So let's look at our choices here. We have that the measure of angle ADC plus the measure of angle DCB plus the measure of angle ABC and the measure of angle, this angle over here is 40 degrees, is 360. That simply tells you have a quadrilateral because the four angles add up to equal 360 because of the whole n minus 2 times 180 formula. For number 2 here, it says the measure of angle DCB, here's DCB, is 40 degrees. And the measure of angle ABC is 140 degrees. Is that enough information? And it is, because that would give you that these two angles are same side interior and they are supplementary. Because you only have 360 degrees in here, if you add 40 and 140 and 40, that leaves 140 for this angle. So you have another pair of same side interior angles supplementary. And so because you have two pairs of same side supplementary angles, you do have a parallelogram. And so that is enough to prove that is a parallelogram. So remember, you have to either know two pairs of opposite angles are congruent, one pair of opposite sides is both parallel and congruent, or two pairs of opposite sides congruent. So we have two pairs of opposite angles are congruent because we had the same side interior are supplementary, which makes our opposite angles congruent. We have two pairs of opposite angles congruent. So all of that works around like a big puzzle to prove that we have parallelogram. 26. Denise constructed angle DEF as shown below using her compass and straight edge. In order to complete her geometry work, Denise must construct an angle bisector. She constructed the bisector EI using the steps below. First step, place your compass on vertex E and open it some width. It doesn't matter how wide it is, just as long as it crosses the two sides of your angle. Swing the arc that intersects both ED and EF, and it could be one solid arc. It doesn't have to be separated like they did here, but it can be. It's fine either way. The next step, label these points as G and H respectively. Place the compass on point G and open, oh my gracious, what did I just do? Here we go. And open it to swing an arc inside of DEF. And so you just put your compass point here on G, open it up to make sure that you have, in a minute, you want an intersection point like they have here inside of the angle. And so you want to swing your arc. And then the next step is to keep that same opening and put your point at H and draw the same arc from H so that you have a point of intersection. So you want to pick the one that says basically that. And that would be D. Place the compass on point H and using the same width as previous, swing an arc that intersects the arc created in step 3. Of course, I'm doing this at school, so we may have some interruptions. I apologize for that, but you guys are my kids, my students, so you understand. The perpendicular bisector of AB is being constructed, first, 2 arcs with center A and radius greater than half of AB are drawn, as shown in the diagram. What that means is you have a segment, and in order to draw the perpendicular bisector, you have to open your compass over halfway across. You might remember me saying that back when we did constructions. It's been a while, but you open your compass over halfway across, and you swing that arc. And sometimes we made it completely, and sometimes you made it above and below. It says, what are the remaining steps of the construction? So the next step would be with the same opening, you would place the compass on B, the point on B, and you would swing an arc above and below AB to cross here at this C and here at this D. And then it would look something like this. Oops, I missed the mark, per the usual. And then here. And then you would connect those, and that would create for you, this is horrible. Why don't we use our tools here, just like in class. Oh, hello, big line. That's a very large line, isn't it? Make that a little bit smaller, okay. And that would give you your perpendicular bisector. Okay. Draw a line through the 2 points of intersection, and that would give you your perpendicular bisector. Good. Number 28. The steps for the construction of a line that is parallel to a given line are listed below. Let me just go through those steps with you, and you can kind of follow along on there. But if you have a line, it says to name it PQ. In order to construct a line parallel to that line, first thing you'll want to do is draw a transversal line, and then you can call the point of intersection. I think it tells us to call the point of intersection that we're going to have up here R, and the point of intersection down here, it calls it J, or maybe I called it J on my picture, I'm not sure, but it says using a straight edge, draw a horizontal line. On the line, mark points P and Q. Then it doesn't have this one, number 2 here. Well, the number 2 would be to draw that transversal line. And so that would be here. Step 2, draw it says transverse line. I always say transversal through R. So they wanted you to call it that point R, where we're going to work in a minute, and across PQ at an angle, forming the point J. That's where J came from, where it intersects the line PQ. The next step says with the compass's width set, it's only one compass, width set to about half the distance between R and J, draw an arc across both lines. So you're going to take your compass and you're going to put the point at J. You're going to swing an arc that crosses your transversal and your original PQ. And then with that same opening, you're going to come up to R and you're going to make the same arc. Of course, this is not accurate because I don't have a compass on my Mimeo, but that's what you would do there. Then you take your compass and you measure from here to here with the opening of your compass. So like you're taking your compass like this and you're measuring that width, and then you're going to move that measurement right here, and it's going to be the same opening as below. And you're just measuring where that line is going to come across right here. And where that line comes across will be your parallel to the PQ there. Okay, so the step that we're missing is move the compass to where the upper arc crosses the transversal and draw an arc across the upper arc, forming point S. So they wanted us to call this point S here. That's that arc that's formed by this compass opening here. And so that was this step where you measure here and then you move your compass up here to measure the same opening. And that gives you a point of intersection here that you connect to form your line that's parallel to PQ. You can back that up and listen to it again. You can also look on the Escambia County website because they also explain it, and they might even have a better picture than mine. Number 29, the steps for the construction of a regular hexagon inscribed in a circle are given below. Draw a circle with center O. So that's your first step. Draw a circle with center O. Once again, why don't we use our tools? Because I can't. There we go. Draw a circle with center O and mark point A on that circle somewhere. Set the width of the compass, the length of OA. So whatever your radius is, you're going to set the width of your compass. You know, you measure it like this. You take your compass. That's this step, actually. You take your compass and you measure from O to A. Then, actually, if A was over here, that's what that would be. You would be measuring your radius. Then you're going to take that width and you're going to start at A and you're going to go around the circle marking with your compass that width. So your next step would be to put your compass point on A and then swing an arc to make point B. And then if you want to keep going, you do it again and again and again and again. And then if it were drawn accurately, it would you would connect these points of intersection and you would have a regular hexagon drawn in here. A regular six-sided figure, which means all six sides, all six angles are congruent. But your next step would be right here. This is not a step at all, but this will be the next step after C. This is the beginning of Antoine's construction. What do you think he is trying to construct? Well, he did construct angle bisectors, but because he's constructing these angle bisectors, it's asking what is the point of intersection or the point of concurrency of angle bisectors. And angle bisectors, point of concurrency is going to be an inscribed circle. And the point of concurrency of perpendicular bisectors will be the circumscribed circle. So this one is for the inscribed circle. It has to do with angle bisectors. You're bisecting angles. Perpendicular bisectors are bisecting the sides and forming right angles with those sides. Number 31. Benjamin visited an art show and saw a painting he really wanted to purchase, but it was very expensive. In the gift shop, he found that he could buy a postcard of the painting at a much more affordable price. The postcard was 4 inches by 6 inches, and it said that it was 2/7 the size of the original. What are the dimensions of the original painting? So we have a 4-inch by 6-inch postcard. And what I like to do is think of this in words, and it might help you also. This is 2/7. Here's how I'll say it. 2/7 of what is 4. So if you do this for the 4 and you do this for the 6, you'll figure out the dimensions. And if you remember from elementary school, of means times and is means equals. And what means you have a variable. You may not have learned that part in elementary school, but maybe in pre-algebra. So 2/7 of what? So times x. X would be your variable. I should have put a dot here for your multiplication and x for your what, but is 4. And then over here you would have 2/7 of what is 6. Because these numbers, 4 and 6, are 2/7 of the original size. So you want to read through the words and try to figure out what in the world do they mean. So then you just have an algebraic equation to solve. You want to get rid of the 7 that's divided by multiplying on each side. That gives you 2x equals 28. So x is 14 on this side. So that would be your, I guess, your length. Or your width, however, if it's a portrait or a landscape, I'm not sure. And then times 7 on each side here to give you 2x equals 42. So that gives me 21 as that dimension. And so it is a 14-inch by 21-inch original painting. So that answer would be B. So think it through that way and work it out. This was mainly algebra more so than geometry, although you're comparing two rectangles. But yeah, think that through, write it out. This one says write the coordinates of the vertices after a dilation with a scale factor of 5 centered at the origin. So whenever you have a scale factor of 5, that means it's increasing by 5. So all you have to do here is multiply the x by 5 and the y by 5. So negative 2 times 5 is negative 10. Negative 1 times 5 is negative 5. Negative 2 again times 5 is negative 10. 2 times 5 is positive 10. 2 times 5 is 10, and negative 1 times 5 is negative 5. So that's simple. Whenever you have a dilation, you just multiply. So if it's a fraction, you multiply by the fraction, or you divide by the number on the bottom. Fraction. If there's a 1 on top. 33. What is the scale factor of the dilation with center at the origin shown in the figure? Ask yourself, what do I multiply the original by to get the new? So what I did was I looked at my original A, my original, let's write it this way, B, and my original C. And then I looked at my new A prime, B prime, and C prime. Let's just look at your coordinates over there. A prime is at negative 4, negative 4. B prime is at negative 2, 4. And C prime is at 4, 2. And if you notice, there is a pattern here. The x's, negative 2 to negative 4. The y's, negative 2 to negative 4. The x's for the b's, negative 1 to negative 2, 2 to 4 are the y's. The x's 2 to 4, the y's 1 to 2. So every single time here, I'm multiplying by 2. So my scale factor will be 2. I'm getting, and it is getting bigger. You want to think about the logic of what you've done here. The purple is your original pre-image, and you're getting bigger to your new image. So it's, if you multiply by 2, that means it's going to get bigger. If it's by 1/2, that means it's going to be half the size. So think it through before you pick an answer. This one, the coordinates of trapezoid EFGH are, and here they are. The image of EFGH under dilation is the letters with the primes. If the coordinates of vertex E prime are 1, 2, what are the coordinates of vertex H? Justify your response by demonstrating how you determine the scale factor in using that to determine coordinates of H prime. So my E is 4, 8. My E prime is 1, 2. Okay, to go from 4 to 1 and to go from 8 to 2 each time, you divide by 2. To determine your scale factor, you want to put your new image over your original pre-image and basically reduce the fraction. 1 over 4, 2 over 8, they all reduce to 1 over 4. And I did not mean to put a 2 here, I apologize. To go from 4 to 1 and from 8 to 2, you divide by 4. You do not divide by 2. I don't know if I said 2 and wrote 4, if I actually said 2 and wrote 2, but this should be a 4. Excuse me, glad I caught that. So, since we are dividing by 4 or multiplying by 1/4, and our original H is 8, 8, then to find our new image of H prime, we just divide the 8 by 4 and the other 8 by 4. 2, 2. So how do you go from the original to the new is what you're asking yourself. And here we're dividing by 4. How do you find the scale factor? You put your new image over your pre-image and reduce the fraction. All right, 35. Triangle ABC is similar to triangle PQR, which is correct. Whenever you have similar triangles, the sides are proportional. The sides are in proportion. Here's what I would say to do. I would say turn that triangle on the left to be oriented the same way as the triangle on the right. And so if I do that, let me just match up my letters here. And you can slow this down and look at it again later, but between A and C is my little b, between A and B is my little c, and between C and B is my little a, and I'm going to make my markings here just to show you. C has the 2, A has none, and B has the 1 marking. So all I did was take this triangle and turned it the same way as this one so that the corresponding parts would match up. Now I can see what matches up with what. If I try the first one, little c over little p. First of all, those two don't match up. They're not on the same. They're not in the same spot, same position of those triangles. B and A are in the same triangle, so that one's all over the place. But if I look at B here, P, little p, over little a, look, they're both the left-hand side of the triangle, equals R over C. So those are both that side of the triangle. So B is your answer here. If you look at the other ones, you'll see those are not corresponding parts. But you want to turn the triangles to face the same direction, unless you're really good at doing it in your head, and then match up the parts and pieces, and just know that the corresponding sides are proportional. All right, last one for this video. Consider this diagram of triangle ABC and triangle DEF. Based on the diagram, which of the following statements are true? First of all, because we have base angles congruent, that means we have 2 isosceles triangles. Okay, so that means they can flip around and still be corresponding. The parts could still be corresponding. Congruent base angles means that opposite those base angles, we have congruent sides. So that's why we have isosceles triangles. Similar triangles, sides are proportional, not necessarily congruent. So these first 2 choices would be incorrect because the sides are not congruent. However, when you get to C and D, they are actually both correct, because when you say AB over BC equals DE over EF, you're going left, right, left equals left, right. So left over right equals left over right, basically. When you get to D, BC over AC is congruent to DE over DF. The reason why those are right is because we have isosceles triangles. So this could be turned around, and the FE could be on this side, the DE could be on this side, and they would match up still with the corresponding parts, the corresponding sides being in proportion. They're interchangeable since they're isosceles. All right, we'll pick up with number 37 in the next video. Thanks for watching.